Counterinsurgency operations are fought with cheap turboprop planes because insurgents don't have air forces. But in my world, they are backed by superpowers, trying to take down my country by any means necessary. Following a very successful military operation, the Anti-Technocratic Battalion, or ATB, has begun strikes on my nation. And we responded with this, the IA-02Q Stampede. In real life, counterinsurgency operations are extremely cheap compared to a real war. In fact, using traditional fighter jets is often too overkill to be functional. They're too fast, too expensive, and they aren't really designed to communicate with the ground troops. The A-1 Skyraider, despite being developed at the end of World War II, was extremely useful almost 30 years later in the Vietnam War. It could loiter and go slow for hours. However, it was still a 30-year-old piston-powered propeller plane, and it couldn't handle the dense SBAAs that would be found in the Vietnam War. It was replaced with jets, like the A-37 and the A-7. In modern times, the A-29 Super Tucano, which is the upgraded version of the AT-27, has taken over counterinsurgency operations. It's really cheap, and it's cheap to fly. But it heavily relies on the enemy not being able to effectively shoot back. If the insurgents had an air defense network, the Super Tucano would be toast. If you don't include its modern weapons, it could realistically lose against World War II fighters, like the P-51. Now, replacing the P-51 with an F-16, and you can probably see the issue. The Super Tucano can't do its job because it's fighting for its life. Now imagine if you had something like the Super Tucano, but it could also dogfight with other fighter jets. The IA-02Q, codenamed Stampede, is a low-cost fighter jet with all the tracking equipment you could ever want, including a vast array of passive and active tracking. It's perfect for shooting tanks, SAMs, and enemy jets. Let's take a look at the engineering of the Stampede, and then we'll look at an operation. The fuselage goes from a normal-ish fighter nose to a boxier shape. You'll notice this on my previous plane as well, because that's like my style. On the upper end of the fuselage, you'll notice the main fuel tank, which holds just under half of the total fuel. This placement is to avoid the drunk insurgents shooting into the sky and hoping to hit it. Unless you're upside down, those bullets will never hit the main fuel tank. In addition to this, it saves costs when manufacturing the frame, because making a straight steel piece is a lot cheaper than making a curved steel piece. The abrupt end at the rear, while not good for aerodynamics, is small enough to have a marginal effect, and it is an amazing mounting point for upgraded avionics. The canopy, which took me forever to design, is extremely strong. The A-10, known for its survivability and gun, features two sections: a thinner 1.5mm main bubble, and an armored 44mm front plate. The Stampede basically takes this and averages it out. Featuring a 12mm acrylic main bubble and a 24mm front plate, you get a good amount of strafing strength, and it's extremely tough on all sides. The Smiley intakes have just enough clearance from the main fuselage to avoid the turbulent boundary layer air, and are more than large enough to feed the Brawler ABTF-70 engines. Mounted just behind the cockpit, you'll notice the electric APU and the battery. The electric APU was chosen over a small turbine because, well, there's no real reason, I just didn't want to make another intake. You could chop it up to being easy to maintain and not wanting the maintainers to die servicing 3 turbines. In the nose, just ahead of the first frame loop, an ASO radar is mounted. By simply removing the nose cone, you can service this radar, so there's no maintenance nightmares on this plane. Lastly, the intakes are S-ducted. While usually this is done for stealth, which is banned in my universe, this actually is to fit the landing gear. A wide landing gear gives you a more stable base, which is needed if you intend on landing on dirt runways. While the Stampede isn't designed to go fast, it absolutely can. In optimal conditions, it can hit Mach 2.3 at 35,000 feet. Both heating and drag become issues at this speed, but it's manageable. It's going to be fighting enemy jets, and being able to maneuver is very important, even if that's not the #1 priority. Without just stretching the wings, there's a few ways to increase maneuverability. The two featured on the Stampede are wing fences and alerts. Wing fences prevent tip stalling by directing airflow away from the wingtips. This allows a root stall to happen before a tip stall, and the root stall is much more predictable than the tip stall. The lurks induces vortices down the wing and increases lift significantly. By creating vortices, you can use vortex lift. At high angles of attack, this is like the only way to get lift because your wings are conventionally stalled. Basically, the wings allow the plane to pull extreme AOAs and remain in control. On the wings, there are 6 hardpoints, and while that's not a lot for a traditional cast plane, it's a lot more than the Super Tucano. It's one more. It's literally just one more. Considering the precision that these hardpoints can carry, it makes up for the low count. The Stampede doesn't have a traditional air brake. Instead, it uses the innermost control surfaces and has them deflect 70 degrees. This creates insane amounts of drag, but usually deflecting your control surfaces 70 degrees would stall them out. But using the previously mentioned vortex lift, you can prevent that. Unfortunately, there is one issue where the one that deflects downwards has a chance of hitting very large missiles, which is why you just shift those forwards. The Stampede can maintain a 14 degree per second turn rate at 350 miles per hour, and at 550 it can pull 17. When pulling extreme AOAs like it's designed to, air stops hitting the rudder, and that's really bad. This becomes an issue when air detaches and becomes turbulent. But using my Mark 1 eyeball, I can estimate that this happens between 35 and 45 degrees. The Stampede can't pull that much, and it tops out at 25. Looking at the... It's still quite impressive. By carrying the GM-99V, my custom IR/laser guided missile, it can make up for its low hardpoint count. The GM-99V carries a heavy 130 kilogram warhead, it has good countermeasures, and it's decently fast. It features a tracking range of 16 kilometers with its laser and 10 kilometers with the IR seeker, and it has a data link processor. Additionally, the Stampede can carry 2 ERM-2A Pythons, another one of my custom missiles, or a modified AGM variant. It has a confirmed max takeoff weight of 17.9 tons, meaning it can carry over 9 tons. Not including fuel, that number drops to 5 tons, which is still plenty. There are a few loadouts that this can carry, ranging from an agile fighter to a freight train. A. Light anti-air, 1 radar missile and 1 IR missile per wing. Heavy anti-air, 2 radar missiles and 2 IR missiles per wing. Light air-to-ground, 1 GM-99V and 1 IR missile per wing. Medium air-to-ground, 2 GM-99Vs and 1 IR missile per wing. And E. The freight train, a 1.5 ton drop tank, a GM-99V, and an IR missile per wing. This reduces its turn rate to like 8 degrees per second, which is not good. The Stampede can alternate between being an agile fighter and a heavy cast plane, which is especially important because of how the Stampede will be fighting everything. Insurgent fighters, SPAAs, tanks, infantry, and entrenched positions, just to name a few. What makes counterinsurgency planes so good at their job is the precision that they have. And how do you get precision? Well, you use. As mentioned before, the Stampede features a wide array of sensors, including an FLIR pod, several IRST sensors, an RWR, and an IR missile warning receiver. And, technically, its Grand ASA radar. This severely outclasses the Super Tucano, which only features an FLIR pod and a laser rangefinder, which is actually in the FLIR pod. The Stampede improves on this with redundancy and tracking capabilities. Let's look at each sensor and how they work. An FLIR pod uses a germanium lens which allows thermal energy to pass through. It's effectively a camera, but for heat. By feeding this data to the IR missiles, you can effectively track any target. Modern FLIR pods, like the ones used on the Stampede, also feature a laser rangefinder and a normal camera. This allows the perfect combo for the GM-99V, which uses IR and laser tracking. Similar to the FLIR, it uses a germanium lens and can find heat sources passively. These are backups for the FLIR pod on the Stampede, but can also be used for searching behind the aircraft. RWR. It listens for radio frequencies and translates those to a threat. By detecting how fast something is outputting energy, you can figure out if something is locked onto you. A radar trying to lock onto you will be a lot more aggressive than a radar pointed the other way, obviously. Knowing if someone's locked onto you is useful, hence why the RWR is on the Stampede. And lastly, the ASO radar. Older radars would use one frequency, which made it really easy for RWRs to track them. The ASO radar can split its frequency across thousands of frequencies. The ASO radar has thousands of TR modules, which individually act as tiny little radars. Additionally, since we have thousands of these modules, one failing isn't a big deal. On older radars, like PASO radars, the entire thing would be toast. Before we get to the mission, let's talk about the engine. Sporting two Brawler ABTF-70 engines, each with 75 kilonewtons of static thrust, it's no slouch. And while that's a lot less than other engines like the F404 for example, they're just really small. 70 centimeters is significantly smaller than something like the F404. It makes 75.3 kilonewtons of thrust with its afterburners, 53.3 kilonewtons without, and has a cruising SFC of 22 grams per kilonewton second. SFC, or specific fuel consumption, measures how much fuel you're burning for how much thrust you're getting. 22 grams per kilonewton second means I'm burning 22 grams of fuel for 1 kilonewton of thrust, and that's happening every second. In total, the Stampede gets 150 kilonewtons of static thrust. This is plenty for its lightweight design and can get a 1-to-1 thrust-to-weight ratio on a light load. The cockpit? MFD1, MFD2, IAS, TAS, flight stick, fuel flow, miscellaneous dials, compass, AOA indicator, heading, knobs, and speakers that are hacked to play copyright-free music. Got it? Alright, let's fly out.
Stampede 1, you are confirmed for intercept. Fire at will.
Hey, we're picking something up. Can you point it over there?